Hi everyone and welcome back to Mossy Maths GCSE. Today we're going to be going through the fourth lesson on the topic of trigonometry, which looks at the sine and cosine rules. Now in the previous lessons we've looked at SOHCAHTOA, which is used for finding a missing side or angle of a right angled triangle. Now this is used for non-right angled triangles, so don't confuse the sine and cosine rules with sin x is opposite divided by hypotenuse and cos x is adjacent over hypotenuse. These are completely separate formula that we use for examples like these that we're going to go through in this lesson. The sine rule is here at the top left hand side of the board, and this is a divided by sine a equals b divided by sine b, which equals c divided by sine c, and we use that to find missing lengths. Now for angles we simply flip the fractions upside down and we have this formula here. Now you don't necessarily need to learn that one formula is used for lengths and one for angles. If you can rearrange equations, then you'll simply be able to see that we can turn the fractions upside down and use cross multiplication to make one of these the subject of the equation, and therefore to solve for either an angle or a length. But if rearranging equations isn't necessarily your strong point, then I would recommend that you learn these two separate formulas for finding either missing lengths or missing angles. The first question asks us to calculate the angle ACB to three significant figures. ACB is this angle here, which is labelled x. But what do I mean when I use lowercase a, lowercase b and lowercase c, and then uppercase c, b and a? Well, all this means is that the capital represents the angle. So in this case, the capital A will be this angle here, capital B will be the 75 degrees, and the capital C will be this x degrees here. The lowercase of that is simply the length that corresponds to that angle, and that's always opposite the angle. So in this case, if this is capital C, then lowercase c will be this length here, which is 4 centimetres. If this is capital B here, then lowercase b will be AC, and simply lowercase a is opposite capital A, so this will be the length BC. So when we're told to find ACB, we need to think which ones we can use. Well, we can't use sine A and A because we don't know this angle big A here, and we don't know the lowercase a, which is the length either, so this won't apply. We need to use these two, and it will always be two that we use. So sine B, well in this case B is 75 degrees, divided by lowercase b, which is the length opposite, that's 9 centimetres, is equal to sine C, in this case c is x, that's what we're trying to find, divided by 4, the length opposite that angle. Now we could use cross multiplication and then rearrange it for sine x, but we don't necessarily need to here. We can just multiply both sides by 4 to get rid of the divide by 4 on this side and to leave us with sine x on its own, which is what we need. So we actually end up with sine x is 4 multiplied by sine 75 divided by 9. So if we take the inverse sine of this whole thing, we get x. Remember, to get x from sine x, we use the inverse of sine. So x is simply this whole thing here. So if we type that into our calculator, what we get is 25.4 degrees to three significant figures. Now the second question tells us to calculate y, which is this angle here, and the length QR to three significant figures. So QPR is a triangle, well, it's also a football team, but in this case it's a triangle, and we're told to find y. Well, in this question we don't necessarily need to use the sine rule to find the angle. All we need to do is to subtract 105 plus 53 from 180 degrees, because we should know that all angles in a triangle sum to 180 degrees. And so if we add these two together, what we get is 158. And if we do 180 subtract 58, so subtract 158, what we get is 22 degrees. So that's the size of angle y, and now we need to find the length QR. Okay, so we don't necessarily need to be using A, B and C, it doesn't really matter, as long as we know that the capital letter is the angle and the lowercase of that letter will just be the side opposite. As long as we know that, we don't really need to know that it's A, B and C, we can just use these letters here. Okay, so we're trying to find this here, so we have to use this length and the corresponding angle, which is this angle here, P. So we can say that P divided by sine P is equal to this, which is Q, divided by sine big Q. And again, we're using the top one here because we're trying to find a length rather than an angle. Now we fill in the equation with the values we know. Well, we know that P is what we're trying to find, that's simply QR, divided by sine P, that's sine 53, is equal to 7.1 divided by sine 105. Now we rearrange this for P, so we get P is equal to 7.1 multiplied by sine 53 divided by sine 105, and so P is going to equal 5.87 centimetres. Remember the unit is centimetres here, and that's the three significant figures. So hopefully you've understood the sine rule. All we do is we apply the necessary formula, rearrange it for either sine x or x, the side we're trying to find. And remember, we don't necessarily need to use A, B and C, just know that we always use the length opposite the angle to correspond to that same letter. And as long as we do that, then we won't get mixed up with anything. Now the cosine rule can be used to find an angle or a side, but it's used when we have something that is included. Now what I mean by that is we have an angle that is in between or wedged in between two sides, like this. Here we have the angle A, which is in between these two lengths. So whenever we have an angle in between two lengths, we can apply the cosine rule to find the opposite length. And as you can see, we can't use the sine rule here because we only have one angle and two sides, and we don't have the opposite side, so we don't have this angle here and we don't have this angle here. So we can't simply do that. We have to use this cosine rule, which is that a squared is equal to b squared plus c squared minus 2bc cos a. So the first one says calculate BC, the three significant figures. And BC is the opposite side, so we can actually directly apply this formula. The A, okay, is lowercase, and it still applies that the small letter is opposite the capital letter, the angle. Now the big A, the cos big A, the capital, will always represent the angle that is in between the two lengths next to it. So this will always be the cos A. The A will always be this angle here, and therefore the lowercase a is the side opposite, which in this case is the BC we're trying to find. So all we do is put numbers into this equation. There's no rearranging necessary. A squared is equal to b squared. Now it doesn't matter which one we use as b and c. I mean, for the sake of using the lowercase as the opposite side, we'll say this is c and this is b. So a squared is equal to 7 squared plus 3 squared minus 2 times b, which is 7, times c, which is 3, times cos of the angle, which is 35. So a squared is equal to, now what I would do here is I wouldn't try and type this in all in one go because you're likely to make a mistake. So if you type in 7 squared plus 3 squared first, which is 58, so a squared equals 58 minus this whole thing, which is 2 times 7 times 3 times the cosine of 35 degrees, which gives us 34.4043886. And remember, don't round this because you will lose accuracy in your final answer. If we do 58 minus that, we get a squared, which is 23.59561414. And a is therefore the square root of 23.59561414. So if we do the square root of that, what we get is 4.86 centimetres to 3 significant figures. And we should actually point out that this is BC, because that's what we're told to find. We're only using small a because that's opposite to the capital A, the angle. Okay? And finally, if you like, you can have a go at this at home, but this is a rather challenging question, because we're actually told to find the angle QPR, which is y, to 3 significant figures. Now, when we're trying to find an angle using the cosine rule, and again, we can't use a sine rule because we don't have any angles here. So, we have to apply the cosine rule, but we have to rearrange the formula, and this can get rather tricky. Now, if we're trying to find the angle which is enclosed between the two sides, then this is going to be our B and our C. It doesn't matter which order we use them to, but B and C are these two lengths, and our lowercase a is this length. Now that means that the capital big A will be the y that we're trying to find. So therefore we need to get cos A on its own. So we're trying to rearrange this equation here for cos A. How do we do that? Well, the first thing to do is to isolate the minus 2bc cos A, because this is all together. So if we move these two values of b squared and c squared over to the other side, we'll get the 2bc cos A on its own. So a squared, if we minus the b squared and c squared, that's going to equal minus 2bc cos A. But we don't want minus 2bc cos A. We never really want to have a minus cosine, because that makes things complicated and easy to make mistakes. So if we turn this into a positive by flipping the sign, we simply have to flip the sign of all the values on the left hand side as well. So this minus b squared and c squared will become positive b squared and c squared, and this positive a squared will become a minus a squared. And this will equal 2bc cos A. Now to get cos A on its own now, this is the easiest step. All we do is, because this is all being multiplied together, we simply do the opposite and divide by the 2bc on this side, and then we'll get the cos A on the right hand side on its own. So the cos A is just b squared plus c squared minus a squared, all of this divided by this 2bc. Now we put in the values we have. B can be this one, so 6.9 squared plus 4 squared minus a, which is 4.2 in this case, squared, all divided by 2 times b times c. And that's cos A. So to get A, remember all we do, I'm not going to write this down because of the space that we have here, but all we'd do is to find the A, we'd do the inverse cos of this whole thing. So cos to the minus 1 of this. So what I would recommend doing is first of all working out the numerator of the fraction, the top, writing down the answer to that, then working out the denominator of the fraction, writing that down, then dividing this by this to get cos A, and then do the inverse cos of that answer that we get, just to avoid making any slight errors, because we might need to be using brackets and things, and that can get complicated. So work out the top first, work out the bottom, work out this, and then do the inverse cosine of that answer. And what we should get by doing that is 33.6 degrees. So let's just check that. 6.9 squared plus 4 squared minus 4.2 squared. If we divide that by 2 times 6.9 times 4, we get 0.83 to 2 decimal places. Then we do the inverse cos of that, and we do indeed get 33.6 degrees to 3 significant figures. So that's the angle QPR. So there we are, guys, that's the sine and cosine rules. Thanks a lot for watching the lesson. If you found it helpful, then please do leave a like. If you haven't already, please do subscribe to my channel. And in the next lesson, which will be the final lesson on trigonometry, we'll look at how we can calculate the area of a non-right angled triangle. So that's it for this lesson, and I'll see you in the next and final lesson on trigonometry.